All right, section 11.2 continued. Last example, example number 6. It says Jane calculated that 10 combination 2 to be 4. She then calculated 10 combination 8 to be, this should say, this is a typo, it should say 45. Jane calculated 10 combination 2 to be 40. She then calculated 10 combination 8 to also be 45. So why are these two combinations the same? And the reason for that is you can think of this as selecting two objects from a group of 10. Doesn't matter the order, right? Because we're talking combinations. Is the same as leaving 8 objects, right? Depending on how you word it, from the group of 10. So I could say I'm taking 2 from 10, or I'm going to leave 8 from 10. Or I could say I'm taking 8 from 10 and leaving 2. It's the same thing. It's the same idea. So use factorial notation to show that they are the same. So 10 combination 2 would be 10 factorial divided by n minus r, which is 10 minus 2 factorial times 8 factorial. Well, this simplifies to 10 factorial. Oops, this should be a 2. This simplifies to just 10 factorial divided by 8 factorial, 2 factorial. Well, this is going to be equal to, if I did the formula for 10 combination 8, is 10 factorial over 10 minus 8 factorial times 8 factorial, which is technically the same as 10 factorial, 2 factorial times 8 factorial. So as you can see, the two expressions are the exactly same. So taking r is the same as leaving n minus r. It's the same thing. So prove the following identity. So if I wanted to prove the identity, right, this is a combination identity, I would take n factorial over n minus r factorial times r factorial. This should be the same as n factorial over n minus r factorial, because this whole thing would be my r value in my formula, times n minus r factorial. So if we simplify my second expression, we should end up with this same value. So I get n factorial. Look what happens here. My n's are going to cancel, and a negative times a negative, just an r factorial. I've proven it that they are the same. So give two other equivalent combinations. So could be anything in the world. So 50 combination 12 is going to be equivalent to 50 combination 38. Okay. Or if we wanted to get crazy and evaluate something that can't be evaluated on a calculator, 256,371 combination 3 is going to be equivalent to 256,371 combination, the difference between these two values, which is 256,368, would also be equivalent. So yes, this can be calculated on your calculator, but you might get something that cannot. So you have to recognize that this is going to be equivalent to this. And that is the end of combinations.